Hello, today I'm going to talk about the search for life in the solar system. I have split this subject into two. The previous video I've made is about the inner solar system, and the subject I'll talk about today is the search for life in the outer solar system. Why are we looking for life? That's the first question. NASA and other space agencies have been searching for life elsewhere in our solar system for over 50 years. The reason is that they would like to know if life on Earth is the only sort of life in our solar system. In the outer solar system, temperatures are considerably lower than on Earth, so if we find life here, it's likely to be completely different from life on Earth. The principal indication of a good environment for life is liquid water. So we'll start with the outer solar system's moons, and we'll look principally initially at Jupiter's moons. Jupiter has 4 large moons which are defined as Galilean because they were spotted by Galileo in 1609. Of these, Europa is the most interesting because it has a thick ice crust underlain by a deep liquid water ocean. This is kept liquid by radioactive elements within its core and tidal heating caused by its approach and receding from Jupiter and by other passing moons, so the amount of gravity that the core experiences changes as it stretches and expands and then compresses again. If this ocean is in contact with the moon's rocky surface, which would provide the chemicals for life, that's going to be an indicator that it's very likely going to have life in it. The next of the moons to look at is Ganymede. It's the 3rd of Jupiter's moons, and it's the largest moon in our solar system. It's got a weak magnetic field and an outer layer of water and ice. So it is possible that the lowest layers of this slushy crust may be in contact with the rocky mantle, which would give it the critical chemicals for life. The next moon out, the last of the Galilean moons, is Callisto. And it also has a weak magnetic field. It may be caused by the presence of an internal ocean with high levels of salinity, lots of salt, but it's not known if this is in contact with rock or not. If it is, then life may be possible. Next we'll look at Saturn. The largest of Saturn's moons is Titan, and it's by far the most interesting. It possesses a thick nitrogen atmosphere and methane and ethane lakes, seas and rain. It also has a complex mixture of organic molecules produced by the dissociation of nitrogen and methane by ultraviolet light. However, it is extremely cold at -179 Celsius, that's -290 Fahrenheit, which means that water ice behaves like rock. If life were found on the surface, it would be completely different from life on Earth and would be very uncomfortable at temperatures we find pleasant, so there are unlikely to be any planetary protection issues. Deep beneath its surface, Titan may have a liquid water ocean kept warm by radioactive elements in its core and by some tidal heating. However, this ocean is probably not in contact with this moon's rocky core, though the overlying ice shell is rich in hydrocarbons which leak through from above, which might provide some of the chemicals needed for life. Another of Saturn's moons is Enceladus. It's also ice covered, but it ejects water plumes thousands of kilometres into space from a series of deep crevasses or tiger stripes. Volatiles and organics have been found in these plumes and are believed to be produced by seafloor hydrothermal vents powered by radioactive elements and tidal heating. This means that this moon's ocean is sandwiched between a rocky floor and a thick iced crust. Additionally, there may be more moons in the Saturn system which may have oceans in them, for example Dione and Mimas. Moving on to the outer planet Neptune. Here we come to Triton, which is Neptune's largest moon. It has a thin nitrogen atmosphere replenished by cryovolcanoes and may have a sub-ice ocean kept warm by radioactive elements and tidal heating. It's not known if this ocean is in contact with the core or not, so we don't know if it has the right elements needed by life, but it's a possibility. Beyond that, we come to the Kuiper Belt or Kuiper Belt. Pluto is the largest object in the Kuiper Belt, and is a spherical dwarf planet. It benefits from radioactive elements, tidal heating, and some remnant impact energy from its formation. It has a thin nitrogen and methane atmosphere replenished by cryovolcanoes, which imply the presence of a syrupy ammonia and liquid water ocean. Whether or not it's in the contact with the rocky core isn't known. Finally, to summarise, finding other life forms in our solar system would change our understanding of our place in the cosmos and might provide us with a host of new chemistries to help us survive in the cold of outer space. Thanks for watching.